state in which the person is fully immersed in the activity and always has a sense of possibility that they can achieve something in doing so. And being in the flow has a whole set of characteristics on the right-hand side, which I won't go through. But it's very much what happens with somebody who is a musician, or an athlete, or a surgeon. But when they're engaged in their work, they really enjoy it because they can actually achieve what they want to achieve and even go a little bit further, okay? And so when you're in the flow, when you're in the groove, you want to stay there because it actually feels so good. And cognitive scientists, people who work on the neural side of things, will tell you that certain endomorphins are released when you're in the flow. But I'm not getting into brain chemistry today. So 2 propositions turning from artists to inventors, engineers, and technologists. And the first is this like painters or sculptors or any other person in the arts, inventors and engineers love to be in the flow. And that means that they are constantly producing a range of projects. So on this particular slide here, down at the bottom you can see that from left to right is time. Up and down, the point that I'm trying to make is that if you were to walk into a laboratory, like at my university in the engineering school, or you were to go and look at Thomas Edison's laboratory, that he had from the 1870s to the 1920s, you see there's lots of different projects going on. Several different bench tops covered with different sets of experiments, different activities, and the creative person is moving back and forth from those different experiments, those different projects, because they feed on each other. There's a synergistic effect. And they are engaged in the activity of sort of being there and discovering new things and experiencing that particular process. So that's the first proposition, is that there's a flow, there's a set of activities that technologists are engaged in. The second proposition is one that we often talk about, particularly when we're thinking about policy and we're thinking about shaping innovation and entrepreneurship, which is that these are processes. And process is actually a very deliberate word, which is that we're assuming that they just don't simply happen. That you just don't wake up one day and voila, as a result of genius and luck, are indeed coming up with new innovations. And that if invention is a process, then there are inputs, there's a process, and then there are outputs. And the inputs can be a whole range of things. They can be money, they can be practical skills, they can be resources, they can be friends, they can be all sorts of things. And out the other end, and this is an important point, is the invention process doesn't just simply produce patents, it also can produce newspaper stories, demonstrations, prototypes, a whole range of things. And for students, it's often very helpful for them to understand that there's a range of things that flow up or come out of the invention process. The right-hand side, you may not be able to see it, the egg shape, the ovals make the point that inputs get into the innovation process and outputs come from the innovation process as a result of people, that there are gatekeepers. Okay, so I've showed you 2 slides, proposition 1, proposition 2, what happens when you put them all together. You get a very complicated innovation model, but it allows us to make a couple of interesting points, helpful for students, helpful for us to think about what's going on with engineering, with entrepreneurs. And in particular, what I call your attention to is the role of those gatekeeping functions down on the right-hand side there where I've marked it. Where I've marked it, I'm sorry if it's so small to see, business partner and patent lawyer, okay? Submitted for your consideration. What this diagram says is engineers, technologists, inventors are going from left to right. They're pursuing a horizontal set of activities that they really enjoy. That's what Dr. Joe called the discovery process. They're engaged in discovering new things. They're not necessarily worried about taking things out of that flow of activities in the laboratory to the marketplace. Indeed, for an idea to get out of that flow, that sort of river going from left to right, somebody has to reach in and pull it out. And that's the point that I actually want to make, which is entrepreneurs are the individuals who link technology with markets or needs to create new enterprises. And that turn, that going from the left to right flow to turning to the up and down, making that right turn, is hard work. And that's what I'm trying to visualize in that model. I'm also trying to signal, when I use this with students, that entrepreneurs can be engineers or they can be business people, but they're engaged in having one foot in really kind of being empathetic with the technology and another foot with being empathetic with the marketplace. So how do we help students develop a dual empathy? And empathy is a word that I'm borrowing from design thinking. We often emphasize in design thinking that we're trying to help students have an empathy with customers. But I would argue that students also have to have, or entrepreneurs also have to have an empathy with the technology. They don't have to be technologists, but they have to be incredibly curious about it. They have to be willing to live and kind of experience, at least vicariously, what the scientist and the engineer does. So how do we, help students have this empathy for both the marketplace, for customers, and for the technology? We do a number of things, not all of which I can possibly begin to cover here. So I want to say a few words about the ones that I've highlighted in red. And again, I'm going to because our accent in this panel is on engineering education, I'm going to bear down a little bit more on what we try to do for engineering students. But the same needs to be done for other groups in the university. So before I actually get there, let me just sort of map out the way at least I, in my mind, think about this. On the left-hand side, in this funnel, we're all trying to basically generate lots of ideas, lots of students, lots of participants, and over time, we're trying to kind of ease a certain percentage of those ideas and those student projects down to enterprises that could go to an incubator, could be a startup. Okay, and so the challenge, that we face in the, at least in the undergraduate side of entrepreneurship is this kind of managing this funnel. And really, what I've learned over doing this over a number of years is it's relatively easy to create courses and do much of the stuff that's on the left-hand side of the funnel. And it's clear that there's all sorts of programs and activities that we've heard about at Purdue that really kind of, the annual program just sounds like a great thing to do what's happening on the right, getting student teams or getting faculty teams ready to be incubated. But what do you do about the middle? What do you do about a set of what are actually co-curricular? Sometimes they're in the classroom, sometimes they're out of the classroom. What do you do about those co-curricular activities? And so that's often what I worry about. Okay, so for courses, we've done two things at the University of Virginia. One is we've really created an all-purpose entry-level entrepreneurship course that can be taken by students all over the university, and it's restricted to first and second year students, so students that are just starting their careers. And it's taught by one of our colleagues over in the undergraduate business school, and he has, at any given time, he takes 48 students. He probably could take easily another 70 students each semester. So there's a high demand for this particular course. What I manage is not so much that course, but a suite of electives in technology entrepreneurship. In other words, I think the sweet spot for us at the university is not the entry-level entrepreneurship courses, but another tier of courses that are a little bit more advanced. Because what we found in talking to student groups, talking to alumni groups, is that entrepreneurs are not really worried about taking a whole formal set of courses. The student entrepreneur will arrive one day and they'll say, Professor Carlson, what I need is I need help on finance. And we want to be able to turn around and say, then you need to take this course on finance over here. We have other students that come in and sort of say, what I really want to understand is if I get the money, how am I going to scale up the business? What does startup operations look like? And we think there's an especially interesting opportunity in and around entrepreneurship and government relations. The University of Virginia sits about 100 miles away from Washington, D.C., and a certain number of our graduates, engineering graduates, go back to the Northern Virginia area and work for large consulting firms or government agencies. And they really need to understand that entrepreneurship in the government space can be very different than being an entrepreneur in the private sector. We're working on a minor that is going to be university-wide. It will be housed just sort of for administrative convenience in the undergraduate School of Commerce, but we believe that it will have different flavors. In particular, it's important that the engineering school have its own kind of entrepreneurship product. And so our product will be the technology-focused concentration. But there will be a social entrepreneurship concentration that the School of Public Policy will do. I think there's a possibility that there will be a healthcare concentration as well. The technology entrepreneurship concentration would consist of probably, as we see it, 4 courses. So a very basic business fundamentals class that we actually have Darden faculty and PhD students come to teach for us. A focusing course that I often teach on entrepreneurship as it specifically relates to engineers, and then a finance class and one or more of those electives that I mentioned a moment ago. One of the newest things that we did, and as my graduate professor, my PhD professor would say, he said, "Bane, I cannot emphasize enough," and then what I want to say is, I cannot emphasize enough that the importance of having people, of having coordinators, and having the right people doing those coordination jobs. And I've been very fortunate to hire in the last 6 months a woman, Elizabeth Pyle, who has become my number 2, become the associate director. And she does a variety of things, but the main thing is that she is like your entrepreneurship concierge here, which is she coordinates student needs, student problems with resources that are available across the university. We also have an advisory board of alumni who do a number of things. We hope that they will ultimately contribute to, so that we indeed have an endowed center like they have at Purdue. But more importantly, they are involved in mentoring students. Also, we're working on the whole question of facilities and creative spaces. And if you haven't see or at least admire from the outside the new building that the KFUPM is building, underlines the importance of having the right sort of spaces. We can often talk about virtual mentoring, and we can talk about all sorts of things that can happen online, but at the end of the day, certain types of relationships, that kind of combining the business person with the technology expert, that only happens in a physical space. And we're working right now on what we call the creative corner, which will be an undefined, almost anarchical space inside the engineering school. In other words, it will have lots of whiteboards, it will have lots of tables, but we really don't want to put any more constraints on it, because this is not a space that is being designed from the top down by faculty. It needs to be designed from the bottom up by students, by our entrepreneurs. We also are very fortunate. We have some incredible facilities that we can rope into our immediate ecosystem, which is the state-of-the-art 3D prototyping lab. And indeed, the KFUPM group came to see the 3D lab last year. We also have an entire building that is just dedicated for experiential learning, where students are able to work with not just simple tools and duct tape, but indeed there is actually fairly serious machine tools and heavy equipment that they can do. We have nothing, and that was really kind of a breakthrough, because we're a small engineering school. We're nothing like, and I'm envious of the prototyping facilities that you've heard about at Purdue. But we have a very focused undergraduate space for that experiential learning. And of course, Sean, my colleague, will tell you more about the iLab that he is more deeply involved with, which is indeed the university incubator. So my time is running down. Let me make a couple of points here. What we've learned is it's relatively easy to get engineers to learn the business. We indeed actually have an undergraduate engineering business minor in the university that I also run, and that has at any given time 15 to 20% of all the undergraduate engineers are taking that. And I could easily have 30 to 40% of the student population in that program. So the engineering business minor program run by a historian is actually larger than any of the engineering majors. So you can imagine that there's certain faculty meetings where I'm not the most welcome guy. So, okay, but it's relatively easy to get engineers to get involved in business. And but the flip side of inviting business and humanities students to learn about technology has been far more problematic. And I think for all of us it's an ongoing challenge, which is to figure out how to bring entrepreneurship, how to bring that sort of empathy for technology to lots of to other student populations. The other point is, which I'll make in order to keep moving here, is the bottom one, which is that teaching and research are not separate. And one of the things I want to suggest is that whole flow model of innovation that comes out of my own research, my own work on studying inventors such as Edison and Tesla, but it keeps getting refined as I learn to work with student groups, as we learn to understand what has to happen in an entrepreneurial ecosystem. We have any number of challenges, I'd say, that just point to the top one here, which is you can build the spaces and facilities, but to get the right sort of feeling, of spirit in those places, what sometimes people would call the mojo, is tricky. And we're wrestling with that right now, is that how do you actually, get it so that people want to show up and are able to do the creative space there, do the creative thing there. Last year, one of our speakers talked at some length about an interesting and important facet or way of kind of summing up the importance of entrepreneurship. And he suggested that, across long periods of time, there have been three kinds of universities. It was the medieval university, which focused on the liberal arts. In the 19th century, it was replaced by a university that emphasized the science and the professions. And indeed, my university, Purdue University, are very good American examples of what happens as institutions evolve into serving the professions and become science-centered facilities. The 21st century, in Dr. Biba's model, is going to emphasize entrepreneurship. That at its heart, we need to be creating not just disciplinary experts, but people who are able to integrate all sorts of different things to cross boundaries, that have indeed that dual empathy. And as Steve Jobs reminded us, or at least particularly in this slide, where he stands in front of where he talked about that his life had been at the intersection of technology and the liberal arts, the 21st century will also be at that intersection. And only by helping our students be able to integrate a range of disciplines to cross boundaries, which is at the heart of entrepreneurship, will they be able to produce the breakthrough technologies that we feel are so important. Thank you.
Thank you, Dr. Carlson. I think we have time for one question from the audience. No questions?
Well, you got one all the way there, the gentleman with the red tie.
Thank you very much for the presentation and sharing with us all the success of your university. You gave a couple of examples or quotes from Steve Jobs' quotes. Steve Jobs is one of the people who didn't rely actually on academia and didn't rely on a university to support him. And it seems there is a current trend which is not very pro-academic. Currently, like the Thiel Foundation, for example, who is promoting entrepreneurship outside the university. How do you see the synergy between the university efforts and the external entrepreneur who are more visible maybe currently with breakthrough technologies, for example? There are many examples of that. Do you see them going hand in hand, or is it like, how do you see it evolving in the future?
That's a very good question, and I think my immediate response, I want to reflect, I could reflect on it for some time, is that I would argue that when we pull Steve Jobs or Mark Zuckerman and we use those as exemplars and sort of say that's really where the high technology, the cutting edge stuff is coming from, we actually tend to emphasize the imaginative, the intuitive, the subjective sides of creativity. And what we fail to recognize is all of those real serious technology that is going to change everyday life, is actually going to be cost effective, is going to be efficient, needs the rigorous analysis that it can only be done through science and engineering. And in fact, I've argued that one of our tasks as academics, as university people, is to help the public understand the complexity that it takes a mix of these two things, of business savvy and technological expertise to really bring about significant change. And we tend to shortchange one or the other. And so I'm so glad that you're right that I'm borrowing Steve Jobs, not because I say we should all grow up to be like Steve Jobs, but rather that it helps us focus on what really are the strengths and the potential of engineering schools.